Alright, this video is about the chi-square and how to compute it and how to understand it. We just finished up with the t-test videos. The chi-square is a little bit different from the t-test, but you're going to end up with a p-value just like you did with the t-test, and you can interpret the results from a chi-square similarly. What's the difference between a t-test and a chi-square? In a t-test, you have two variables. One is a category. So we had group A and group B, and that was you could think of that as a single categorical variable that indicated which group a person belonged to. And there was nothing between A or B. It was just you were either A or B, and it didn't make sense to talk about A being less than B or B being less than A because it's a category. And then we had another variable in addition to that categorical variable, which was a continuous variable. And I believe in the data file it was labeled exam score. But we also talked about it in terms of a rating from 1 to 100. It could be anything that has levels where it makes sense to talk about one value being greater or less than another value. So t-tests are good for when you have one categorical variable and one continuous variable like that. Chi-square, on the other hand, is good for when you have one categorical variable and another categorical variable. You have two categorical variables. And this chi-square actually makes a lot more sense in many contexts where you're doing conversion marketing or A/B testing, because a lot of times what you're interested in is the different versions of the website or message that you're showing people, and then whether or not they performed an action. So yes or no, did they perform that action? So did they click on the button or did they not click on the button? And you could think of that as a categorical variable. There was no like almost clicked on the button. Either they clicked or they didn't. So there's a different set of procedures involved to get that p-value. So both the t-test and the chi-square test, you'll end up with you're computing a statistic that will tell you about the p-value and also how big of an effect there was. But and so you can interpret those similarly, but the procedures for getting there are a little bit different. So let me show you those procedures. Let's pretend we've still got group A and group B. That's represented over here to the left. And we've also measured whether or not a particular person in group A or B clicked. So two people, right, there's 10 people in each group, and you can see that over here. Got row totals. So I've just summed up the number of people in that row, and there's 10. Summed up the number of people in that row, and there's 10. So both 10 people in groups A and B for 20 people total, and you can see the total down here is 20. It doesn't matter whether I add up these rows or these rows, they'll both add up to 20. Now, 2 people in group A clicked on the button and 8 people did not click, whereas 3 people in group B clicked on the button and 7 people did not click. So we've got column totals down here. We add those up, 2 and 3 equals 5, so overall 5 people clicked and 15 people didn't click, 8 plus 7. Now there's this idea that will come up in the future in a lot of different areas in statistics, and that is the idea of an expected value. And so how do we have an expected value? Now, expected value is such a horrible label for what this is. It should be something more like average value, maybe. But let me show you how to compute it, and then you'll understand why I don't think it's such a great label. The way we compute that is we take the row total, I have to say this equals the row total times the column total. So we're looking at this particular cell right here. We're coming up with an expected value for this particular cell right here. So we've looked at its particular row total. We've multiplied that by its column total. We're going to put that over the grand total. Now, for the sake of making this easy to do for all 4 of the cells, Gonna put some constant symbols around this. So E is going to change to F, so we'll make that $sign there. The grand total will never change. So whoops, formula I typed contains an error. Oh, I put the $sign after the 5. There we go. So that should be 2.5. 7, and that should just be 2.5 and 7.5 again. Yep. Okay, so it looks like that worked. If we click on these various ones, we are getting the corresponding proper ones. Now, okay, that's correct. That's sort of correct. Okay, there is something incorrect about this, but we still ended up with the correct values. So notice that it's using the top value there. That's because I put the $signs in a spot where they don't exactly belong. So if we just put G4 here, G4, that's still going to be 7.5. We just put G4 right here. There we go. Okay, now we've got everything working the way it should be. So we've got these expected values right here. And again, I said expected value is sort of a bad name for it. It's more something like an average value, but not exactly an average then, is it? And we got that by taking the row total times the column total and putting that over the grand total. So we've got the observed values here, the expected values here. So what we're going to do is actually compute the chi-square value. And the way we do that is, well, it's going to be, we're going to add up a set of numbers, and each one of those numbers is going to be in one of the cells over here to the right. So that computation looks something like this. We take an observed value, from it we subtract the expected value, and we put that in parentheses, and we square it to make sure that it's never negative, and then we put that over the expected value for that particular cell. All right. So we should be able to just drag this around. Should get observed minus expected over expected. That worked. And same thing down here. We should be able to drag this down here. Observed minus expected over expected. And the same thing over here. Okay, and now we can actually compute the chi-square, and the chi-square is very simple to compute now that we have those numbers. We just add up all 4 of these numbers, all the different cells, and we have a chi-square value of 0.26666, etc. And just like with the t-test, the chi-square has degrees of freedom associated with it. And it's similar to that for the t-test. This one is rows minus 1 times columns minus 1. So we have 2 rows and we have 2 columns. This is a 2 by 2 chi-square. 2 minus 1 is 1 times columns minus 1, which would be 2 minus 1 is 1. So 1 times 1 equals 1. So for this 2 by 2, we have a degrees of freedom that equals 1. And I uploaded a couple of chi-square tables to the course website, so you can check this yourself. But if you just look here, here's a chi-square distribution table. We have degrees of freedom equals to 1 over here on the left. And if we look over and try to find a value that's close to our chi-square value, it jumps from 0.016 to 2.706. So ours is somewhere in there, meaning we know it's probably not significant because we have these really high numbers up here. And then here's another chi-square table with better probability marks, more specific probability information up here at the top. We'll go to degrees of freedom 1, and if we go over to a value that's close to ours, well, 0.46 will be closest to ours. So we got a probability of 0.50. Since ours is actually a little less than 0.46, our chi-square value is a little less than 0.46, we'd expect our actual p-value to be, in reality, a little higher than 0.50. And if you have downloaded this file already from the course website, you'll see that that Excel actually has a chi-square function on it. So if I go here, and in that chi-square, that will give you a p-value. So we go to chi-test, and we have actual range. Notice that it's asking for an actual range and an expected range. So I'll put the actual range here, comma, expected range here, and it gives us a p-value of 0.6055. So I guess that would be, if we rounded up to 2 decimal spots, that would be 0.61. So that's our actual chi-square value, and we interpret that in a very specific way. With chi-square variables, what we're trying to say is whether or not there is a relationship between the row variable and the column variable. So is there some sort of relationship between these two categorical variables? So in other words, in this case, did one of the groups, group A versus group B, click more than the other group? And we want this p-value to be as low as possible. Remember, it ranges between 0 and 1. So the closer it is to 0, the less likely it is that this is some type of false positive. So in this case, we can't really conclude that it isn't a false positive because 60% chance is pretty high. So we say, okay, there's probably not much of a difference between group A and group B.